Okay, so this is the last talk, and so I'm the last obstacle between you and the lunch. So we'll try to be fast. We already had a presentation on, that spoke a little bit about PowSyBl, but I would like to enter a little bit more into the project, and more especially about what at Artelys we do. I think beyond what I'm going to present, it's I would like to present you the business models that we have and the good things and the difficulties that we can have with a business model linked with open source, and how we can make it continue to make it more appealing to everybody so that it develops. So just a general presentation on PowSyBl. So it's an open source framework named Power System Blocks. So from the start, it meant that it's not a product, it's a set of blocks that you can integrate to make a product or a solution. It's dedicated to electrical grid modeling and simulation. It is under the LFE governance, which is, in my opinion, very important because, well, you can put open source code if you want, but making sure that you have the governance so that many people can really develop it, and not only use it, it's something else. So we have a technical steering committee with the developers that are maintaining it. There are many repositories, so each developer is responsible for some repository, and they jointly decide on the roadmap on what will be the official version of PowSyBl. So right now in the technical steering committee, you have RTE, Artelys, and the AIA. It's a public meeting every month, and that's important to give visibility and transparency, especially to Artelys customer. Because somehow, as you will see, when a customer asks us to do changes into PowSyBl, then we go to present it to this technical steering committee and agree with the others on how we are going to do the changes. It's a commercial-friendly license, weekly contaminating, and in my opinion, this is the best trade-off. Meaning that it's not contaminating, you can mix it with proprietary software, but at the same time, there is a strong incentive to redistribute the modifications that are done. So you can choose MPLv2, LGPL or something like that, but that's a good trade-off in my opinion. So right now, we have a large community, many users. It's in operations by European transmission system operators and some RCCs, regional coordination centers. On the functional side, well, nothing fancy compared to Panda Power or the others, I would say. You can have power flows, OPFs, security analysis, dynamic simulation. No surprises either on grid formats. A strong focus maybe on SIM, CGMES. Somehow PowSyBl started a bit together. Was thought at the beginning of SIM. So from the start, the SIM importer was important, and making sure that we have a good compatibility with SIM remains important. To be honest, data exchanges between TSOs goes way beyond any tool. It's a very complex subject. Adoption of SIM is taking years, and we try to foster it. It's not an easy issue. But we think that PowSyBl in particular can be a reference because it's we want it to be the reference for CGMES computation. Being open source gives you the transparency to do that, so that it can be a kind of benchmark well, against any other tool that wants to implement it. You can manage grid modeling, format extension, grid extraction. And then also what's important now is that it was made as an enterprise-grade software from the start. So meaning that the goal was to have something that could be run in operations for control room software. It means that Java was chosen for the integration that you could have with the remaining part of the system, and also with all the tools that come with Java, like vulnerability assessment and all the CI/CD tools that allows you to make a seamless integration with most software that is Java-based. Also, we have, from the start, it was decided that the internal data format would be versioned, so that when you have old archives in internal format, you are still able to read them with the new software. And thanks to the Linux Foundation Energy, we have improved a lot on the cybersecurity side, setting up the processes to have the OpenSSF Silver badge that includes processes to tell when you see vulnerabilities and address them, processes to make sure that the CI/CD platform is safe, and that kind of things. And so at the beginning, it was really an enterprise-grade software, and that was not usable by ordinary power system engineers that don't know how to code into Java. So that quite quickly, a Python interface was made, quite complex one based on GraalVM, but that works quite well. And thanks to this Python interface, it started to be, it was way largely used by the power systems community. Some visualization tools were introduced that allows you to do a network and substation visualization directly into your Jupyter notebook. And so in the end, it is now rather user-friendly. We can speak about documentation, but for an open source project, the documentation, I think, is already quite good with a lot of examples. You can test also with GPT-5, knows well how to code into PowSyBl. So you can ask GPT-5 if you want starters for some use cases. So that's the general presentation of PowSyBl. So at Artelys, we don't use everything that's in PowSyBl, but part of it. And the main three computation modules that I'm going to present today are metrics, OpenLoadFlow, and OpenRAW. So indeed, Artelys is focused on computation modules. So we usually do not provide full platforms. Sometimes it could happen that we do, but we prefer to focus on our skills that are linked to computation modules and studies using these modules. So in Planification, you have PowSyBl metrics that is mainly used to do grid reinforcement studies. So if you want to do a cost-benefit analysis to know whether a new line is useful to reinforce your grid, or whether you should wait to build it. So this tool, to the best of my knowledge, has no equivalent. I've never seen something like a real competitor to this tool. It contains an optimized economic redispatching simulator, so an OPF, a DC OPF, and the performances are really, really fast. It's 100 times faster than a standard DC load flow, and it does optimization. And one of the things, there are many things to come with these results. It's well integrated, of course. It comes with its own integer linear programming solver, and it has a lot of tricks implemented to do the computation. And it's quite flexible in terms of computation, so that you can adapt to the needs of your customers. In operations, we have the workhorse of a power system, which is the load flow, called OpenLoadFlow. It also does, it's called OpenLoadFlow, but it does not only do the load flow, it does the security analysis and the sensitivity factor computation. It's an AC and DC load flow that does grid merging, and has advanced grid modeling. So for those, for those who are interested, last year we implemented shared remote reactive control. So it's already hard to say, but it's even harder to understand what it does exactly. But I can tell you that you can find it in SIM CGMES files from European TSOs. It does a security analysis, N-K contingency analysis, pre and post contingency actions, and it's distributed over HPC platform for scalability reasons. Last but not least, the sensitivity analysis. PTDFs, PSDFs, anything you need. Said like that, it does not seem that impressive, but if you don't have a good sensitivity analysis, you will never have a good security constraint OPF. So this one was really developed and tuned to have optimization and especially OpenRAW in mind. So the last column of this table is OpenRAW, which is the optimizer. And OpenRAW relies heavily on OpenLoad flow, and the performances of OpenRAW are really linked to the fact that OpenLoad flow is very performant to compute sensitivity factors. So the last column is OpenRAW. Well, I mean, we were not that inventive on names, so OpenRAW is just a remedial action optimizer. You can have you can model a lot of remedial actions, topological actions, phase shifter transformer taps, set point, HVDC set point, redispatching, pre and post contingency. It was tuned for capacity calculation, which is the computation in which you try to optimize the configuration of the grid to maximize the possible power flows between two bidding zones. So it's in a European context. Or you can use it for redispatching and counter-trading, which is the second use case that is more recent, where you try to minimize congestion management costs. So let's have a small focus on metrics. So it's a security constraint DC approximation optimal power flow for those who like the standard names of tools that does preventive and curative remedial actions. And so with it, as I told you, you can do what-if analysis by adding a line to your grid and compute, for example, the decrease of redispatching or the decrease of losses that comes with your new line. And what's very important is to model very well the grid. So the redispatching is basic, but making sure you are close to the operation of the grid with all the post-contingency remedial action, the right strategy to manage PSTs, HVDC lines is very important. Because it's quite often that in planning that you simplify too much, and that in the end you say, oh, the line is useful, and then when it comes to operation, it's not useful because the grid is not operated as you modeled it. So, and that means that the tool is really useful to start from the beginning, that is base case grid model, contingencies, redispatching costs, and then give you all the KPIs that you need in terms of curtailment, loss of load, and all the indicators that you need to assess the benefits of a new line. So for example, just as an example, at Artelys we used it to see how much more renewable energy could be hosted in the Latvian grid thanks to the use of advanced grid management technologies like DLR, curative actions, or PSTs. And so we computed, we tried to increase the amount of wind power that was connected to the grid, and so at which point the curtailment of the grid of the wind farms was too high. And we set it at 5%, which is already quite high. And then if you have a smart grid management, then you can, thanks to curative remedial action or DLR, you can insert more renewable without curtailing that much the renewable. So we computed the amount of renewable energy, the increased hosting capacity, that is how many more gigawatts of wind farm you can connect to the grid, and remaining at 5% of curtailment, which is quite useful for the TSO then to plan the rollout of these technologies. So let's say, okay, we are going to start with preventive redispatching, and then we will do DLR, and then we will end up with curative redispatching, or whether it's going to be in another way around, so that they can roadmap the deployment of these new technologies. So open load flow. So open load flow is used now by quite many TSOs and RCCs. So the biggest customer for Artelys is the CoreNet program, which is managed by CoReso and TSCnet, for which we have right now in operation since December last year a SIM CGMES merging. So the merging is basically rather simple. You receive individual grid models from all Europe, all TSOs, not only from the TSOs that are shareholder of TSCnet of CoReso, but from all TSOs. And then you merge them into a single grid model on which you can do European-wide computation like security analysis. It's quite complex, especially when you don't have the data, because you have many islands to manage, islands on which you cannot scale the consumption because or the generation because there are no generators. So to make it work in the finest details, taking into account all the peculiarity of the IGMs of 30 TSOs, well, it takes quite a lot of time. But now it works, and we are hoping that TSOs will send better and better data quality, so that the statistics that are really regularly issued by CoReso and TSCnet, and the amount of IGMs that were merged will increase. Beyond the European merging function, in the CoreNet program, or only with CoReso, depending on the case, we have also been doing security analysis, and then some capacity calculation, and finally working on. There is also an implementation of the flow decomposition of the future cost-sharing process that has been implemented into PowSyBl. So it's a methodology that requires to identify the origin of the flows on a line that is congested. And well, it's a difficult problem because it's not only an engineering problem, because when there is a line that is congested, it's impossible to say which generator or which extent that congested it with in an easy way. You have some arbitrary choice to make to understand who made the congestions, and this is known as flow coloring problem. And the methodology that was approved by Acer has been implemented into PowSyBl, and should be used for the implementation at CoReso and TSCnet. And the last tool is OpenRAW. So OpenRAW, maybe it's the tool that is the easier to understand. You take the grid as it is forecasted for tomorrow, and then it's full of congestion because the result of the scheduling of the generation results in issues that were not anticipated, because there is more wind, there is less wind, and also because the generation is scheduled at the zonal level, and sometimes the zones are not adequate, are not adapted to the real flow pattern, so that you have to do redispatching within bidding zones, as it was shown in the previous presentation. So in this case, you run the remedial action optimizer that takes all the nodal constraints into consideration and find the optimal way to address them by applying non-costly actions, that is a topological switching, or changing the set point of PST or HVDC lines. And then when it cannot do only with costly action, it does counter trading or redispatching, trying to minimize the costs. So PowSyBl OpenRAW is used at Coreso, mainly as a capacity calculation tool. It's an operation on four ATC borders for several years. It's not yet in operation for counter trading or dispatching, but we are working on it. So now I presented you some of the experience that Artelys has with using PowSyBl, both as a user of metrics, for example, but also as a developer, especially of OpenLoadFlow. And I would like to come back to the business model. So I appreciated the presentation of Min this morning because, well, honestly, yeah, it's more difficult to have for a business to have a business model based on open source than on licenses. So right now the business model is is the following. So Artelys is selling development, support, and maintenance servicing using PowSyBl modules. So the IP of the code and of the documentation is kept by the customer. The customer pays for the development and keeps everything. But Artelys open sources the code and the documentation on behalf of the customer. But if you go to see a PowSyBl repository, for most of the code that Artelys made, it's written copyright, TSCnet, and Coreso, because they paid. So that's why it's not written copyright Artelys in the repos. No license fees paid by the customer. And the other business model, which is, it consists in using PowSyBl in studies. So in this case, we use our tools called Artelys Crystal Supergrid, in which we integrate PowSyBl, or we use directly PowSyBl tool like PowSyBl Metrics. So we deliver modules. PowSyBl is a set of modules, so we do an assembly and an integration of modules that may be different for each customer. Most of the time, as I told you, we focus only on computation module, and we have a partner that does the integration, like Unicorn for Coreso and TSCnet for Cornet. But there are challenges. So the economics does not change. So there need to be some reuse of the code so that to share the development burden and the development and the cost overall of maintenance and support between a reasonable number of customers that share the same needs. I would say 4 or 5 for a typical computation modules is needed. Else, you will if you have only one customer using the computation module, the maintenance and support will be rather expensive for this customer and may switch to a proprietary solution that is used by many customers, so that the support and maintenance costs are split among them. The main challenge for me is that with great powers come great responsibilities. So we gave back power to the customers, but they have to invest proactively because we do not have license fees anymore to do the investment. So they have to understand that sometimes there is a need to invest in non-functional features, and that they will have to pay for that, for some refactoring that are needed to go further. And so there is a need of some kind of governance and of understanding of the customers for that. Else, it's going to be a tragedy of commons in that everybody is using it, but nobody is paying to improve it. So I think the LF energy governance is key to overcome these challenges, to make open source competitive with proprietary software, because it creates awareness. I mean, this conference shows it. It creates transparency with the monthly, especially with the monthly public technical steering committees, and of course the code that is open source that you can see. So the overall result is that, well, each year I present the same slides if you were there last year, but each year there are new customers. So last year I had RT and Coreso and TSCnet. This year I've got Baltic RCC, Seleni RCC, and Elia, for which Artelys is providing maintenance and support development services around PowSyBl. So it works, but still with the challenges that I mentioned before. So my final slide is about what's needed to gain momentum. So we see that it can work, even if we need to strengthen it. But what do we need? There are many TSOs in Europe. We need increased awareness about PowSyBl, both the technical abilities of PowSyBl, but also the organizational ecosystem and the fact that, there is enough skills to provide the same quality of service as proprietary software when it comes to these computation modules. Especially, there is Artelys, and there are other software, other vendors that can provide support and maintenance services around PowSyBl. And then, this is the last point I would like to insist today, is that we need PowSyBl-friendly public tender contracts. So I would say from the easiest to the most difficult, I've read a lot of draft contracts for in tenders, and then each time it's the same thing. So if really the customer is convinced that PowSyBl is a good solution, then, well, the second point here, you can ask, the customer can ask the bidders to use PowSyBl. So it can be mandatory to use PowSyBl. It's allowed by the law. It's not against public procurement. I quoted the report from the LFE that stated the condition under which you can require an open source solution in the requirement. So it's feasible, and of course, it will help a lot, both the current players in the ecosystem, but also to develop it, because all the people that want to bid will have to look at PowSyBl and will be interested in competing when providing services around PowSyBl. If not, then at least it should be open source friendly in that the vendor should be allowed to publish modification to the existing PowSyBl code. Usually, the draft contracts say that the purchaser keeps the full IP, and that's all. But then, I've got to negotiate each time the right to publish the modification as open source. This could be in the contract, so it could be something like that the purchaser keeps the full IP, but the vendor is allowed to use non-contaminating open source libraries for which the modification will be released as open source, even if the purchaser keeps the IP. This is really important. This is the basic to foster collaboration and to allow a vendor like a service provider like Artelys to use PowSyBl. And last but well, it's more difficult, the last point is that we should find ways to set up governance to allow open sourcing of additional new modules without needing contract amendments. Because right now it's just too difficult. Let's say we did something new, but the contract is what it is. It's almost impossible to release it open source. It's going to be a hassle in terms of involvement of the legal department of the customers and in order to be able to publish a new module, even if it would be beneficiary to everybody, because this new module could be used by other customers to share the development and the support and maintenance burden. So, well, I'm already late, so sorry. I did not keep my promise to be short, but if you have any questions, I'm happy to answer, and else we can discuss during the lunch break.